Alrighty, here we're going to dive into what is a huge topic in AP Calculus, and that is function analysis. So basically what we're interested in is things like maximums and minimums of functions and areas where they are decreasing or where they're increasing. And specifically what we're interested in is what can the derivative of a function tell us about those features. My hope is, now that we've spent a lot of time on just the concept of the derivative, this lesson is going to come pretty easily. What I want to start by doing is just tackling our graph of g and just annotating some of these features. So I'm going to use a bunch of colors here. I suggest you do as well. I'm going to start by highlighting our increasing intervals. And then the notation we use to write these intervals down, this is familiar from pre-calc. I'd say from negative infinity to 0. These are x values, by the way, so all the way to the left until we get to 0, and we use a bracket here by convention. This is my first increasing interval, and then my second increasing interval would be from 2 to infinity, and again 2 gets a bracket, infinity gets parentheses by convention. And then notice we also have a decreasing interval here in the middle that I'm going to use a different color for, and that interval is from 0 to 2. Again, these are x values, and these would get brackets by convention. This is a decreasing interval of g. Okay, and the reason we want to annotate all of these is because we're going to start to look at the relationship between these areas and the derivative. Before we do that, we want to note that this is what is called a relative maximum, and that is at the point 0, 0, and that's just a point 0, 0, right? And then we have a relative min down here, and that is at the point, let's see, 2, negative 4. Okay, so those are all the properties of g we're interested in analyzing, and we are going to look at the relationship between g and g prime. So notice I label both of these. That's always a good thing to annotate, especially on the AP exam, what the graph is. G prime is just a really simple polynomial derivative. We'll take that derivative right now, and it's just power rule 3x squared minus 6x. And that's the equation. It makes sense that we have a parabola, right, for g prime because the degree is 2. So now what we're going to do here is we're going to annotate the same intervals in the same color. So I'm going to start with negative infinity to 0 in blue on g prime. Negative infinity to 0 would be like that, and then we also annotate 2 to 0. So notice on these intervals where my function was increasing, we have g prime is greater than 0 on both of these intervals. And then my third interval was from 0 to 2, and here we have g prime is less than 0. And then at my maximums and my minimums, we had x equals 0 and x equals 2. My derivative changes signs, right? So this relationship makes perfect sense, right? So I'd have a positive derivative where my function is increasing, a negative derivative where my function is decreasing, and a sign change where it changes from increasing to decreasing, right? So that is really the key to this lesson, is this relationship between the graph of g and the graph of g prime. And it makes perfect sense as long as you remember that this graph, g prime, is a graph of the slope of g. Like a lot of things in calculus, we can apply this in a lot of different ways. So we're going to go through 3 examples now of different ways to use this knowledge. My first is just algebraically. So we had this function g of x is equal to x to the third minus 3x squared, and then g prime of x, again this is just power rule 3x squared minus 6x. Okay, so algebraically what we find useful usually is to set our derivative equal to 0, and these are going to be polynomials that usually we're going to solve by factoring. So this you know how to do from algebra 1, algebra 2. So I undistributed the 3x in this case. Sometimes you'll factor into 2 binomials. And then my zeros are each factor equal to 0. So here are my zeros. And notice these were my maximums and my minimums up here. Now, let's say I wanted to analyze this graph of g here, but I didn't know what the graph looked like already. What I might do is I might make myself what is called a sign chart. And I'm going to label my sign chart for g prime. And I'm going to graph my zeros. So my zeros were 0 and 2. And what I want to know is the sign of my derivative in each region so I can start to imagine what the graph would look like, right? So I just found my zeros. All I'm going to do now is I'm going to pick x values to plug in to test. So I'm going to be like g prime of -1 is to the left of 0 maybe, right? I could have picked -5, but -1 is going to be easier. That's going to be 3 times 1 plus 6 is 9, right? So I just figured out that that region is a positive region. In the middle, I would obviously probably pick 1 would be easy, although I could pick like 0.5 if I wanted to, right? G prime of 1 is going to be 1 times 3 minus 6 is going to be -3. So I just figured out that that region is negative. And then over here, I could pick maybe G prime of 3, and that would give me 3 times 9 is 27 minus 6 is 21. So I just figured out that region is positive. So this is a way, especially if you don't have access to a calculator, of figuring out the information that was given in the graph here, right? Let's fill out our glossary, and then let's return to our sign chart and see what conclusions we might draw. So when f is decreasing, we would say f prime is negative. When f is increasing, we say f prime is positive. At a maximum, f prime changes. Let's see, a maximum we're going from increasing to decreasing. So changes from positive to negative. And at a minimum, f prime changes from negative to positive because we're going from decreasing to increasing at a minimum. So notice, we could make several conclusions based on a sign chart. There's lots of questions we could answer. Here, we might say G has a maximum at x equals 0 because G prime changes signs from positive to negative. This, by the way, is the justification you'd be expected to write on the AP exam. Alrighty. Critical values, by the way, I said it was going to be important where the derivative is equal to 0. So those are critical values of the function. For these examples, I'm going to draw first the sign chart, and then I'm going to write the solutions based on the sign chart. What I suggest you do is pause the video each time, do the sign chart on your own, and then do the solutions on your own once you've checked your sign chart against mine. Okay, so here I've made my sign chart. So first I found the zeros from the factors, and then I plugged in a value in each region to find these. Make sure you can figure out how I got those values, and then I label just positive and negative. Next we're going to do decreasing intervals, increasing intervals, and maxes and minimums. So again, we'll pause for a second, see if you can't write these out on your own, and then we will also write the justification that is expected of you in the AP exam. Okay, so here are my solutions. So I have increasing and decreasing intervals citing the derivative, positive versus negative, right? And notice I'm talking about the signs of the derivative. And then for maximums and minimums, I'm talking about my sign changes, so positive to negative for maximums, negative to positive for minimums. So example 3, we're given again g prime of x, and we have this function h of x in there. Let's not worry about that just yet. Let's definitely worry about this little polynomial guy. So 9 minus x squared is equal to, by factoring, 3 minus x, 3 plus x. Again, we're going to make a sign chart for this. Obviously, my zeros are going to be -3 and 3. Go ahead and finish the sign chart on your own for just this polynomial to start. So here's my sign chart, but be careful here, because this is the sign chart for just 9 minus x squared. So g prime of x is 9 minus x squared times h of x. And what we are told, right, is that h of x is always negative. So that means we're multiplying this polynomial by a negative term. That's going to flip our sign chart. Right, so our zeros are going to be the same. because negative times 0 is still 0, but the signs are going to flip. This one is very tricky, right? And then we want to know at what values does g of x have a relative maximum. That value is, of course, negative 3, because we have g prime changing from positive to negative at that value. Okay, so this is obviously the hardest example, what we're building towards here with these sign charts.